Hello, my math independent study student. In this video, we are going to simplify a fractional exponent, and we want to write them as a radical to a power. So if you can look at this this formula here, so if I have x at the base and m over n is the exponent. Now your exponent is the fraction. So I'm going to write it that way here. The base is x, and the exponent is the fraction m over n. So if you have a fraction exponent, you can write them as a radical to a power. So now your denominator, so which is n, it will become the root or the index. The m now becomes the power. So you can see I'm going to write that n root of x to the power m, or I can say n root x and all of that to the power m. Now you can see, look at the example here. Here we want you to write this number 27 to the power 2 over 3. So 27 to the power 2 over 3 at a radical. So it means that first of all, I want to look at my fraction exponent. I have my n is 3, my m is 2. Okay, so we'll start with the n, but with the denominator at 3, so therefore the root will be 3. And then we'll put 27 inside the radicals, and then I'm gonna put the power 2 outside. So this is how I came up with. And the next one, so here, if we have 27, if we write them as a prime factor, it will be 3 times 3 times 3. Right? So 27 is 3 to the power 3. So if I have the root 3 of 27, this will be the same thing as the root 3 of 3 to the power 3. Now think about how can we go backward. If we have n roots of x to the power m, we can write them as the base to the fraction exponent. So this will be the same thing as 3 to the power of 3 over 3. So the exponent, the fraction exponent is gone. It's just 1, so you get 3 to the power 1, which is 3. So inside q root of 27 will give me 3, and then the exponent outside the 2, so 3 squared will give me 9. So the answer will be 9. Now let's do more example. Let's do the next one now. So here so again I'm going to write out the formula again. If we have x is the base and the exponent is the fraction m over n, so we have the base, we have a base with a fraction exponent, and we can write this at a radical with the root at n, so n root of x, all of that to the power m. Or you can write that n root of x to the power m. Okay. So we're going to apply it here. So again, here we want you to write from the radical to a fraction exponent, to a fractional exponent. So we have our n. So I make a note right here. N is 4. Here m is 6. So therefore I'm using this formula here. So therefore my base is y, and we'll write them as a fraction to 6 over 4. Now the way I write this down maybe a little bit confusing, so I'm going to write this 6 over 4. Now 6 over 4, these two numbers both have 2 at the common factor, so we go ahead and divide them by 2. So 6 divided by 2 is 3, and 4 divided by 2 is 2, so we can write them as y to the power 3 over 2. So the answer will be y to the power 3 over 2. So let's look at the next one, example 3. So in this example, you have the root of 3, so 3 root of a times x to the power 5, y to the power 6, and z to the power 11. So the first thing you're going to do is that you want to go ahead and break or each one of this so under the radical there are 4 factors. So you break this into 4 factors with the same root. So you have cube root of a, cube root of x to the power 5, cube root of y to the power 6, and then cube root of z to the power 11. Okay, so the next step now we are going to simplify. So let's look at the cube root of a first. Cube root of a. Now a is 2 to the power 3. So if your root and your power is exactly the same, think about if I write them as a fraction, exponent will be just 1. So therefore it gives me 2. So the first, so cube root of a is 2. So the next one we have cube root of x to the power 5. The goal is that if you have your root and your power exactly, so your n and your m exactly the same number, then that will give you 1. So it means that you'll be able to cancel out your radical. So in this case, we'll go ahead and write them as cube root of x to the power 3 times cube root of x squared. Why? Because x to the power 5 using the product rule of the law of exponent, so it will be x cubed times x squared. So now this will give me just x, and then the second term I cannot simplify, so it will stay the same. So that's why we have x times cube root of x squared. So we do the same thing for the next one. So we have cube root of y to the power 6. Now you can see right here that 6 and 3, they will be able to divide out without the remainder. So I'm going to write them as a fraction exponent right away. So it will be 6 over 3. So simplify, so that will give me 2. So you have y squared. And the next one, z to the power, okay, I run out of space. Let me see if I can find somewhere to write it down for you. So let me just keep going. Okay, so the next one here, which is cube root of z to the power of 11. Okay, so we have cube root of z to the power of 11. So first of all, 11 divided by 3, it will have remainder. So I'm going to go ahead and break it down. So cube root of, now 11 will be 9 plus 2. So I'm going to with z to the power 9 times cube root of z to the power 2. So so the first one, 9 divided by 3. I'm going to write them as a fraction exponent. And the next one, I'll keep them at the radical, so cube root of z squared. So now 9 divided by 3 will give us 3, so that's where we get z to the power 3 times cube root of z squared. So now the next step, you want to go into that, you want to go look for the root that have the same index. So you have right here cube root of x squared and then cube root of z squared. So if you have the roots that have the same index, so you can multiply the term under your radical side. So in this case will be x squared times z squared with the same root. And that will be the answer for this expression. Make sure you write out and write out your own summary. And thank you so much for watching this video. Goodbye.